All right, so 14.7, complex fractions. There are two ways that you can simplify complex fraction. We'll look at the first method, and then the second method you can use at any point in time. First method, you have to have a certain type of setup, and I'll show you what I mean in a second. But what makes a fraction complex is when you have, well, we know what a fraction is. If we were to just look in general, what a fraction is 4 over 5. Now, if I were to place that 4 over 5 over another number, now the fraction is considered complex. In other words, I have a fraction here, and then I have a whole fraction here. Or if I were to do 4 over 5, 7 over 6. So I have one fraction, two fractions, three fractions, all together. So that's what makes it complex when you have more than one fraction involved or embedded in another fraction, something like that. So let's go back to the notes. All right. So the first method we will implement if you have one solid fraction over another solid fraction. And you'll see what I mean. Matter of fact, I'll scroll down. So here, notice how here we have one fraction, 2, 3, 4. And you have a plus sign in between or a minus sign in between. So method one would be hard to do because then you would have to combine these fractions and then combine these fractions. And so that's what I mean by a solid fraction. If you have one fraction over one fraction, that's when method one would come into play. So what you would do, here we have 4w squared over 5rs over divided by 20wr over s squared. So this division sign is the same one as this one right here. So we go from writing it vertically to horizontally. So I haven't changed anything. It's just that we wrote it. First we were writing it vertically. Now we're writing it horizontally. All right. So once you have that, then whenever you don't forget, whenever you divide by a fraction, you multiply by the reciprocal. So this division changed to multiplication, and then we flip this fraction. So now we have s squared over 20wr. So before we go any further, make sure we're okay with what we've done. We had the fraction written vertically. We wrote it horizontally. And then whenever you're dividing, you're multiplying by the reciprocal. So the division changed to multiplication. And then we flip the fraction that follows the division sign. All right. So from there, you go ahead and reduce, cancel out what's in common. So let me erase this stuff before you can see what I wrote. So that 4w squared is 4ww. 5rs is on bottom. S squared is ss. Then I broke up that 20 into 4 times 5, wr. And so now you would cancel out what's in common with the top and bottom. So my 4's cancel. W's can only one of the W's will cancel. One of the S's will cancel. And that's it. Now those 5's can't cancel. The 5's are both in the denominator. So they stay in the denominator. And so if you multiply what's left, in the numerator you have WS. In the denominator, 5 times 5 is 25. R times R is R squared. And that will be your most simplified expression. Questions? Any questions on that? All right. Let's try another one. Here we have y minus 8 over 5y divided by 3y minus 24 over 15. So once again here, one solid fraction over one solid fraction. So we can rewrite it horizontally. So we go from writing it this way to writing it this way. So that division sign, once again, that division bar is the same thing as the division sign over here. All right. Division changes to multiplication. Flip this fraction. All right, so then we'll factor. All right, so y minus 8 over 5y, and then that 15 is 3 times 5, and then I factored out 3. Factored out 3 from this 3y minus 24. That's why I have 3 times y minus 8. And then you cancel out what's in common with the top and bottom. So that whole quantity of y minus 8 will cancel. 3's will cancel. And then 5 will cancel. So if you notice in the numerator, everything in the numerator canceled. So that'll leave you with just this 1. And then everything in the denominator canceled, except for the y. So that's why you have y, 1 over y for your final answer. All right, problems with the cancellation.
Sorry, I'm late. I'm overslept.
That's all good. All right. Everybody still copying? Make sure we're good before I go up. All right.
One quick question. What section number is this?
14.7.
Okay.
All right. So here we have the second method. And once again, like I mentioned earlier, the second method will work no matter what the situation is, no matter what the setup. But it most definitely is more beneficial when you have separate fractions here. You know, we have 1, 2, 3, 4 quantities. You know, your plus signs, your minus signs will separate your terms. So going back here, notice this was one whole fraction over one whole fraction. So that's why we could just go to this. But you can't go there. Let me do that. You can't go there when you have this situation because you have these different terms. So the easiest way to handle this type of problem is to first find your LCD. So we see in our denominator, the only thing we see is A. So that is our least common denominator. And then we're going to multiply. Oh, let me see if I wrote it. No, I didn't write it. So we're going to multiply each numerator by the LCD. Same thought process that we used when we were solving equations and we were trying to clear out our fractions. We will multiply each numerator by the LCD. So I'm going to multiply each term by A. All right. Doing so will give you AB over A plus 7AB, and then AB plus 2AB over A. We're talking about right here. When you multiply each numerator by A, that's what the result would be. And then what that allows is for these A's to cancel here, A's to cancel here, and this would be a more simplified answer. B plus 7 AB over AB plus 2B. So now, of course, as always, somebody say something?
Yeah, so when we cancel out, we can't, can we cancel out the 7AB? I mean, the AB and the 7, and then the other AB in the denominator? Or only the
You're
little
talking about AB's right here?
Mm-hmm.
Oh, no, because of that plus sign.
Oh, okay.
Yep, these plus signs stop you from doing it like that. Yep.
Okay, so we could only cancel out the ones in the smaller fractions, right?
Right.
Okay.
So you cancel out those first, and then you look at what you have to see if you could cancel out anything else. But once again, just in case you guys missed what she was saying, she was asking, could she cancel out an AB? If you see an AB here, could you do it in here, there? The only way you could do something like that is if there were no plus signs. So if it was 7AB over AB, you could cancel out the AB. But those plus signs and minus signs, they prevent you from doing things like that. So that was a good question. Let me go back, move these circles. All right. So looking at it right here, we're not finished because if we look, we can factor out a b from the numerator and denominator. And so the only reason we can cancel out a b next is because b was able to be factored out at each term. And notice there's no plus sign in between, your b's right here. It's all about multiplication. So if you have that scenario, then you can go ahead and cancel out. And then that will leave you with 7a plus 1 over a plus 2 as your final or most simplified answer. All right, make sure we're okay. Excuse me. Scroll up. Is everybody okay? All right, let me erase some of this stuff. All right, so of course we're not looking at this yet. We'll talk about the process first. So we have 8 over x squared plus 1 over x. 2 over x squared minus 1 over x is the original problem. First thing you want to do is establish what your LCD is, and that will be x squared. We have x squared and x in the first two numerators. Then in the bottom, we have x squared and x as well. So x squared would be that LCD. The highest power of x will always be or the highest power of your variable will always be your LCD. And just like we mentioned in the last problem, you take that LCD and multiply it to each numerator. All right. Once again, we're not doing top and bottom. We're doing each numerator. So that will give us 8x squared over x squared plus x squared over x. Then 2x squared over x squared minus x squared over x. All right. The whole x squared will cancel here. And this next one, x squared is, that would be 2x's. So only one of those x's will cancel out. Leaving you with just 1x. Here, the whole x squared will cancel. And then the same thing here, one of your x's cancel, leaving you with just the 1x. And so your result is in this box, 8 plus x over 2 minus x. If you have any questions. All right, can I scroll up? Everybody okay? All right, so the next one, n to the negative second power minus m to the negative second power over m to the negative first power plus n to the negative first power. So don't forget your negative exponents, what that forces us to do. If I want to write them as a positive, I can take them down to our denominator. So that n to the negative second power is 1 over n squared. Same thing with m to the negative second power, 1 over m squared. And then the other ones, you drop those down to the denominator as well, 1 over m plus 1 over n. Problems with that transition, make sure we're okay. So from there, we find our LCD. So remember before, when I had x squared and x, my LCD was x squared. So the same thing happens here. I have n squared and m squared, m and n. So my highest power, my variables will be my LCD. And so that's why I have m squared, n squared. And I'm going to multiply each numerator by m squared, n squared. All right. So you multiply m squared, n squared to each numerator. And then you cancel out what's in common with the top and bottom. All right, so in the first one, n squared cancels. Second one, m squared cancels. And the third one, just one of the m's cancel, leaving you with m. And the second one of the n's cancel, leaving you with n. And this is our result. M squared minus n squared over mn squared plus m squared n, m squared n. All right, so let's factor. Here we have a difference of squares in that numerator. So that's going to be m plus n, m minus n. Then the denominator, we can factor out the GCF, which is mn. So if you pull an m and an n out of this first term, you're left with n. Pull an m and an n out of the second term, you're left with m. And then we see that m plus n cancels, or in common with the top and bottom, so they will cancel. And that leaves us with m minus n over mn. Any questions? Look at another one. All right. Here we have 1 minus 1 over x minus 6 over x squared over 1 minus 10 over x plus 21 over x squared. All right. LCD, once again, is x squared. So we're going to multiply each numerator by x squared. That will give us this result. So we have x squared times 1, which is just x squared. And it's minus x squared over x, minus 6x squared over over x squared. And we have x squared minus 10x squared over x plus 21x squared over x squared. All right, so now you want to cancel where you can. X cancels here, leave you with 1x. All of x squared cancels here. One of your x's cancels down here, and all of your x squared cancels here. leaving you with this result: x squared minus x minus 6 over x squared minus 10x plus 21. Then we will factor. So x squared minus x minus 6 will give you x minus 3x plus 2. X minus 7 over x minus 3 would come from x squared minus 10x plus 21. X minus 3's cancel, leaving you with just x plus 2 over x minus 7. Any questions? All right, I got another one down here. All right, so here, x over 11 plus 10 over x plus 1. Then we have 10 over x minus 11 over x plus 1. All right, LCD is a combination of both of your different denominators. We have x and x plus 1. So your LCD will be x times x plus 1. All right. Then once again, you multiply each numerator by the LCD, which is x times x plus 1. So this is that result. Multiply each numerator by x times x plus 1. All right, so now we'll cancel some stuff out. X cancels here. X plus 1 cancels here. X cancels here. X plus 1 cancels here. So this is the result of that. It leaves you with x times x plus 1 plus 10x over 10 times x plus 1 minus 11x. And once again, those plus and minus signs like this prevents us from just canceling out quantities and stuff like that. So we're going to have to distribute and simplify. All right, so distributing this 11 and this 10, that'll give us 11x plus 11 plus 10x. So we're looking at right here, 10x plus 10 minus 11x. And so then you combine your like terms, 11x plus that 10x in the numerator will be 21x plus 11. 10x minus 11x, that'll be 10 minus x. Any questions? Any questions? All right. See what's going on here. Hey, this was just an abstract question. Oh, we could do them anyway. Got a lot of stuff going on here, so hold on a second. This must have been something somebody asked about because I didn't do it in any type of flow. All right, this is what we'll do. I got 1 over 4x. Oh, okay, yeah, these are just abstract questions. Okay, gotcha. So I probably should have did something like this. All right, so before we do anything else, questions on 14.7. That's what 14.7 is on. Like I said, those other things are just abstract notes people were asking about.
Tell me the name of the section, please.
Complex fractions.
Complex fractions.
Mm-hmm.
I missed the first half of the notes. Can I stay for a few minutes and try to get that whatever I missed for those first minutes?
Mm-hmm. All right, so let's see. So that's it for chapter 14. Next class, I'll open the floor for questions. If you anyone don't have any, then we'll, go ahead into chapter 17. But I will give you guys the floor first. That's it for chapter 14. Any questions before I close out today, as far as the lecture is concerned? Everybody good? Everybody straight? Anybody have any questions on anything they got stuck on? All right, so get in there. Don't forget, we're getting ready to close out, y'all. We only have a couple weeks left, so make sure we grind as much as we can to get this stuff done. If you're behind, as far as you guys are concerned, you're held responsible for up to chapter 14. Like I said before, I don't know if we're gonna get to chapter 18, but it's all good, and we will go from there. All right, so you guys have a good one. Be safe. I'll see you next class, and take care.
Can you go back to the beginning?
Hold on a second.
Okay.
All right, have a good one.
Hey, you should do the same.